This final note section, we're looking at circle section 3. We're dealing with equations of circles. An equation of a circle is always going to follow this basic format right here. And that is when you have the center HK. By that we mean the x coordinate of the center gets paired up with the letter x in this equation. The y coordinate of the center gets paired up with y in the equation, and then the radius r is plugged in here. So for example, if we had the center 3, 2, if that was the center of the circle, we would write x minus 3 squared plus y minus 2 squared. And if our radius was, let's say, let's use 3 as our radius. Radius is 3, would equal 3 squared, or would equal 9. That's the way you're going to see the formula for a circle written out. This next part is, how would we get that if we got something in a different form? So if we had everything expanded out, our x squareds, our y squareds, things like that, it wasn't nicely wrapped up, how would we solve it? And we're going to use something called completing the square. You might have seen this before in Algebra 1. What we're going to do is kind of work through step by step. We're going to start out with the concept. So what number would be needed to complete this equation? X minus what squared is equal to x squared minus 10x plus 25. If you were to factor this, so let's work backwards for a second. If you were to factor this, you would say, what are two numbers that multiply to 25 and add to negative 10? Well, numbers that multiply to 25, you've got 1 and 25, you've got 5 and 5, and that's about it. Or you could have negatives of all of these. So 5 and 5 multiply to 25, 5 and 5 add to 10. If you made them both negative, now they still multiply to positive 25, but they add to negative 10. So negative 5 and negative 5 are the two numbers that we need. So we would say x and then minus 5, x minus 5. Since our factor is the same factor twice, we could write it as x minus 5, that entire group, squared. Squared just means the whole thing times itself. So the answer to the original question is, what would be needed to complete this equation? X minus 5 squared is what we're missing. So now what we're going to do is figure out a shortcut to that. If we look at this relationship, what's always going to happen is if we take that middle number and cut it in half, that's going to be the number we need. Now sometimes we need to do extra stuff to make sure that this ends up being 25. It ends up being whatever the right number is there. So we might need to do extra work for that. But we can always rely on taking half of the coefficient of x to get the term that goes in here. Let's work through some steps here. You get all of the terms with x squared, x, y squared, and y on the left side of the equation, and you get everything else, the constants, or the numbers, to the right. So the constants are the numbers that don't have an x or a y, a variable with them. The second step you're going to do is you're going to take half of the coefficient of the x term. So you're going to take half of the coefficient of the x term, whatever number is next to x, kind of like we did up here. Half of negative 10 is negative 5. Then we're going to square it, and then we're going to add it to both sides of the equation. When I said we need to make sure that we get that perfect number, in this case 25, we would actually do that ourselves. We would add 25 to both sides. We're going to repeat this with the y, so we're going to have some y squareds minus maybe 6y. We would take half of that, square it, and add it to both sides. So we're going to do it with x and y. Last thing is we write the x group in factored form. And the factored form is where we have something like x plus something squared. That's what we mean by factored form. We're going to do the same thing with the y group. So it'll be y maybe minus something squared. And on the right side, we're going to end up having three numbers. Our original number, and then we added something to both sides for the x's, we added something to both sides for the y's, and we add that all up and we clean it up into a single number. And when you do that, you have completed the square. It will leave you with a formula that looks something like this one we have up here, where it's easy to find the center and radius of our circle. Now for the examples, we're going to go through that on the actual page with the problem, so you can skip ahead to those videos to see examples of this in action.